Ladies and gentlemen, welcome to 5 Technology News. This is your host, Dr. Yavuz Selim Salai, physician, entrepreneur, and venture architect. First and foremost, I want to thank you for making 5TN one of the most viewed technology shows across Africa. I'm really thrilled and excited about the messages we're receiving and your interest across Africa for technology. Let's get to our top 5 news in technology. My first news is about flying cars. Yes, you heard it right. New Hampshire in the United States is the first state to allow flying cars on the road. My second news is about artificial intelligence that mimics the brain, needs sleep, just like humans, one of the studies revealed. And ladies and gentlemen, Amazon, Google, Facebook, name it, all of these tech powers are now shifting tactics, and Europe is actually limiting these tech powers in this new phase. My fourth news is about Disney. Disney's new artificial intelligence is facial recognition for animation. My final news is about open artificial intelligence. OpenAI's latest breakthrough is astonishingly powerful, but still fighting its flaws. Let's get back to our first news. New Hampshire has become the first state to allow flying cars on the road. We have been promised flying cars for seemingly decades, and although we still don't have one ready for production, New Hampshire has gone ahead and given them the okay. New Hampshire is the first state to allow flying cars on the road. Will New Hampshire suddenly look like GTA 5? No, but the state's ready to let them hit the road legally. Just recently, the Granite State passed House Bill 1182, as known as the Jetson Bill, into law. The transportation bill includes a provision that makes flying cars legal on public roads. There aren't any to hit the roads today, but it's a future-forward gesture, I suppose. To be clear, the legislation doesn't let future flying cars zip above roadways, but it does allow them to operate as a traditional vehicle on public roads. Essentially, it lets tomorrow's drivers, pilots, drive to the airport and then take off towards the skies, and no funny business either. Flying cars will not be allowed to take off and land on public roads. Although they don't exist today, there are 2 companies that continue to aggressively pursue this segment. Terrafugia is probably the biggest name after China's Geely purchased the Massachusetts-based startup. However, the company has gone rather quiet in the past couple of years. The company told Roadshow it has 100 people working on its flying car project, maintains strong support from Geely, and eyes leadership in urban air mobility. The second one is Samson Sky. The Oregon-based startup originally planned to have its flying car, the Switchblade, ready in 2019 after making a big splash in 2018. We last received an update on the prototype almost a year ago, but it appears the company is still humming along. Samsung Sky also did not immediately return a request on its flying car status. So even if we do get a true flying car, one today, it's unlikely they will perform exactly the way we watched them in the Jetsons. In reality, vertical takeoff and landing contraptions, or VTOLs, will probably get closer to the futuristic way of life. Ladies and gentlemen, my second news is about artificial intelligence. Artificial intelligence that mimics the brain needs sleep, just like humans, one of the studies revealed.
Too long. And how did that make you feel? What about after you got some sleep? Do you think your computer would feel that good if it got some sleep too? Well, a new study from the Los Alamos National Lab shows that some kinds of artificial intelligence, or AI, might benefit from sleep, just like we do. To understand how that could be possible, let's take a look at how sleep works for us. Your brain is an electrochemical organ, which means that the brain cells, or neurons, that make up your brain transmit signals to each other via tiny electric impulses, or brain waves. These brain waves fire faster or slower depending on what you're doing. They're pretty fast or high frequency when you're awake and engaged in something like watching a really cool science video. And when you start to fall asleep, your brainwaves start to slow down, and they go through several stages until you reach deep sleep or slow wave sleep. Over the course of a night, you actually cycle through all these different sleep stages, going from slow wave sleep back up to lighter sleep, where you might experience dreaming, and all the way back down. Scientists are still working to understand exactly what slow wave sleep does for us, but it seems to be involved in refreshing and repairing brain cells and other systems of the body that have been working hard all day. That's why you feel so much better after having a good night's rest. Now, a team of researchers thinks that similar benefits of sleep might help keep artificial intelligence programs running smoothly too. They're using a special kind of program called a spiking neural network to try and approximate how humans perceive and recognize images. Neural networks in general are computer algorithms that are really good at recognizing patterns, like interpreting this handwritten number 7 correctly. And they're built to mimic how our brains do that task. A spiking neural network is a special type that goes one step further, and it mimics how the brain's neurons fire in bursts rather than all the time. This is really hard to do, but the payoff is huge in terms of power efficiency. Just think of all the amazing things your brain can do, and it only runs on about 20 watts of power. That's less power than it takes to power a laptop computer. The research team gave their program a particular task called unsupervised dictionary learning, which is a fancy way of saying they gave it some images to look at, and then they asked it to come up with a dictionary of visual elements, the words, to describe them. By using this kind of training for their neural network, they were hoping to recreate how humans learn from their environment during childhood just by taking in their surroundings. So it's a little like handing you a cookie and asking you to figure out the recipe just by eating it. You could probably come up with some good ideas all on your own, that is unsupervised. And that's what this team of researchers did with their spiking neural network, but with images instead of cookies. They gave their AI many images, and these are all from a well-known data set of tiny pictures, just 32 pixels on a side. So you can sort of see a pixelated car, a frog if you squint, and a blurry truck. It actually doesn't matter what's in the picture or how crisp the image is, because they're interested here in whether the program can learn how to reproduce the images. So left to its own devices, they set this program to learn a dictionary of visual words, and it came up with something like this. This might look a little strange, but the important thing to notice is how different these little squares all are from each other. They have different patterns and colors, so that between all of them, they make up a whole vocabulary to describe lots of different images. Then, from combinations of these strange-looking words, the team asked their AI to recreate the original images. Imagine if we asked you to bake the same cookies just based on what you learned from eating one. You might get pretty close, and so did they. It seems like the program really did learn what some of the most important visual elements are to describe the images they started with, to a pretty good extent. But they ran into an unexpected problem along the way. During these unsupervised learning periods, the spiking neural network started to become unstable, meaning that the nodes in the network would get carried away and they would start spiking in response to just noise. And then soon they were firing all the time and they were completely messing up the simulation. Here's what their dictionary started to look like over time. So at first it's going through the images bit by bit, and some reasonable looking visual words start to show up with different patterns. But then as it keeps learning, the nodes just start spiking all the time and the words start to all look the same. They become meaningless. The researchers struggled to figure out what was going wrong until they tried something a little unusual. They broke up the unsupervised learning periods and spaced them out with naps. In between short bursts of learning from the actual images, they started showing the AI fake images that were just noise, and they changed the noise over time in this wave-like pattern. When they set the AI to learn its dictionary this time, it behaved very differently. Instead of the spikes growing continuously over time, they calmed down. And after some learning, they started to see some reasonable visual words showing up in their learned dictionary. And after even more learning, instead of becoming all the same and meaningless, they became more distinct and unique, which became more useful to them. It's what they wanted. So these little naps calmed down the spiking neurons and kept them from hallucinating. This sleep-inspired technique is likely to be useful for all sorts of future applications, and they want to use it next on a neuromorphic chip, which is a hardware piece specifically designed for these types of programs. They also wonder what this research might tell us about our own brains, and they speculate that maybe one reason why slow wave sleep may have evolved our own neurons on task.
Artificial intelligence is an amazing area that many researchers are looking at. And researchers at Los Alamos discover neural networks rehabs benefits equivalent to a good night's rest. Artificial intelligence designed to function like a human could require periods of rest similar to those needed by biological brains. So the researchers at Los Alamos National Laboratory in the United States discovered that neural networks experience benefits that were the equivalent of a good night's rest when exposed to an artificial analog of sleep. We were fascinated by the prospect of training a neuromorphic processor in a manner analogs to how humans and other biological systems learn from their environment during childhood development, said Yijing Watson, a computer scientist at Los Alamos. The discovery was made by the team of researchers while working on a form of artificial intelligence designed to mimic how humans learn to see. The AI became unstable during long periods of unsupervised learning as it attempted to classify objects using their dictionary definitions without having any prior examples to compare them to. When exposed to a state that is similar to what a human brain experiences during sleep, the neural network's stability was restored. A paper detailing the research will be presented, and it is continuing in different organizations and conferences. The vast majority of machine learning, deep learning, and AI researchers never encounter this issue because in the very artificial systems they study and they have the luxury of performing global mathematical operations that have the effect of regulating the overall dynamical gain of the system. Let's look at the third news. This is a new phase, ladies and gentlemen. Europe shifts tactics to limit tax power. So when we say the tax, we are talking about Amazon, Facebook, Google, and Apple. So the region's lawmakers and regulators are taking direct aim at Amazon, Facebook, Google, and Apple in a series of proposed laws. The European Union leaders are pursuing a new law to make it legal for Amazon and Apple to give their own products preferential treatment over those of rivals that are sold on their online stores. In Britain, officials are drawing up a law to force Facebook to make its services work more easily with rival social networks and to push Google to share some search data with smaller competitors. And in Germany, authorities are debating a rule that would let regulators essentially halt certain business practices at the tech companies during an antitrust investigation. Europe's lawmakers and regulators have shifted to a new stage in their battle to limit the power of the world's biggest tech companies. The region has long been at the forefront of using existing antitrust laws and levying multi-billion-dollar penalties against the tech giants. But officials now say that those tactics have not gone far enough in altering the behavior of Apple, Amazon, Google, and Facebook. So they are drafting at least half a dozen of new laws and regulations to aim at the heart of those tech companies, businesses, and how they work. Europe has embarked on its legal blitz just as the United States of America has started flexing its own tech regulatory muscles. The chief executives of Amazon, Apple, Google, and Facebook were grilled by lawmakers in a congressional hearing to scrutinize their power. All defended themselves against criticism from Democrats about anti-competitive business practices and accusations from Republicans that they were muzzling conservative voices. So all four companies showed their financial muscle by reporting billions of dollars in profits and surging revenue. So the momentum in the United States is set to grow. The Justice Department is expected to announce an antitrust case against Google, and the Federal Trade Commission and state attorneys general are also investigating Facebook, Apple, and Amazon for potential anti-competitive behavior. Those actions, coupled with efforts in Europe, represents a double whammy for the tech giants. If the proposed laws in Europe are enacted, the policies could lead to a major overhaul of the region's digital economy, where there are more than 500 million consumers, by regulating the tech companies more like traditional industries such as telecommunications and finance. This is a new phase. Margaret Vestager, the European Commission Executive Vice President, who is leading the efforts in Brussels, mentioned that in a new interview. So Mr. Vestager said the proposed laws would lower hurdles to force the tech companies to change and even restrict them from moving into new product areas. At stake is whether or not these markets will be open and contestable and innovative, or if they will just be governed by these walled gardens of de facto monopolies, she said. European officials are working on the new laws against big tech alongside more traditional tactics, such as antitrust investigations. European Union officials are investigating whether Apple's App Store policies are anti-competitive and are preparing charges against Amazon for abusing its e-commerce dominance to box out smaller rivals. The European Union is also reviewing Google's purchase of wearables maker Fitbit, while Britain opened an inquiry back in June into Facebook's acquisition of Giphy, a GIF company. So Google, Facebook, Apple, and Amazon are closely monitoring Europe's proposals. While the companies have publicly said they want to work with the region's lawmakers and regulators, their lobbying groups have argued that Europe's aggressive actions are partially an effort to protect homegrown industries. Popular tech services are increasingly being developed outside the EU, said Christian Borgren, Vice President of the Computer and Communications Industry Association, an industry group in Brussels. So the EU should strive to become a leader in tech innovation, not just in tech regulation. So for years, Europe set the standard in tech regulation, only to find that its efforts did not make much of a dent as the tech behemoths continued to grow. Consider that the European Commission found Google guilty of antitrust violations 3 times from 2017 to 2019, resulting in fines roughly of 8.25 billion euros, about $9.7 billion at the current conversion rates. So the cases each took several years to complete, giving Google ample time to secure its dominance in online advertising, smartphone software, and internet search. The monetary penalties, which are small for a company with more than $160 billion in annual revenue, remain tied up in court appeals. Other legal efforts, such as Europe's landmark privacy law called the General Data Protection Regulation, were aimed at many industries and were not just aimed at the tech companies. Since GDPR was enacted in 2018, it has been faulted for lack of enforcement. So over the past year, European regulators and lawmakers began a concerted effort to draw up new laws that specifically honed on the tech companies' businesses. So much of the energy came from officials in Brussels, where European Union leaders set policies for the 27-nation bloc. So back in December, Mrs. Vestager, who has already spent 5 years as the world's top tech industry watchdog, began a new 5-year term leading digital policy and antitrust oversight. She and her colleagues vowed to take an even harder line. They proposed new rules to make it easier for regulators to begin investigations against the tech companies. One proposed law, the Digital Services Act, would draw more businesses' boundaries for search engines, marketplaces, social networks, and app stores. Policymakers are debating barring Amazon, Apple, and others from giving their products preferential treatment in their digital stores. Mrs. Vestager said there was broad political support for the ideas, which will become law by next year. Among European countries, Britain has become particularly active in moving to rein in the tech giants. Lawmakers are debating the creation of a regulator to focus on the largest tech companies, holding them to new codes of conduct so they do not exploit or exclude the business practices. So, ladies and gentlemen, when we look at it, it is going to be a very interesting time for these companies, and they will definitely be scrutinized more and more for what they are doing. So while they're generating huge value, of course, at the same time, in Europe, each of these policymakers are debating new laws. For example, in France, the policymakers are looking into a new law that would censor hate speech online, making Facebook, YouTube, and Twitter legally liable for content posted by users. So Germany has adopted a similar proposal, and Britain and the United European Union, as well as Turkey, are considering such measures as well. France is also looking into an effort with Italy and the European Union to force the tech companies to pay more taxes. So many hurdles remain before the proposals become law. Some question whether the regulations would be effective, particularly if they take years to enact. So when we look at it, it is going to be a very interesting development. And ladies and gentlemen, we will see what will happen. But at the end, as William Kovacic, a professor specializing in antitrust law at George Washington University, says, Even if many of the proposals did not become law, the increased scrutiny alone would lead the tech companies to change behavior. It's like the policeman at your elbow. So ladies and gentlemen, let's get to our fourth news. Disney's new artificial intelligence is facial recognition for animation.
We present high-resolution neural face swapping for visual effects, an unsupervised deep learning method for generating high-definition, multi-way, photorealistic transfers of source appearances to target actors. Our method produces compelling and convincing results that are difficult to distinguish from genuine images. In our pipeline, we begin with data for the behavior we want to model. We perform face alignment by detecting facial landmarks. We transform and normalize the face to 1024 by 1024 resolution. We then feed it into our model and decode it as any one of the source appearances our model is trained for. We then blend the generated face with the target background using a contrast-preserving, multi-band compositing process. The method encodes multiple faces in a shared latent space via its common encoder and decodes images using multiple decoders specialized for individual faces. This has the effect of disentangling static identity information from dynamic behavioral information. This makes any performance transferable between any two identities in our data. Facial landmark labeling can be unstable from frame to frame when working in high resolution, so we introduce a routine to correct for these errors. The effect of the correction is subtle but noticeable. Notice in the clip on the right the quivering of the mouth and the slight rotation of the face below the eyebrows. Those artifacts are not visible in the clip on the left. Our model supports a progressive training regime that allows us to generate high-definition video at a resolution and level of realism far beyond competing methods. This training process also allows us to avoid a number of artifacts that occur if the model is trained end-to-end at full resolution. To achieve convincing full-face swaps, we apply a contrast-preserving multi-band compositing process, which achieves nearly seamless blending of generated images with target backgrounds while maintaining the color and lighting characteristics of the target image. Our multi-way model not only allows any pair of identities in our data to be swapped, but also provides for richer representations of facial behavior. Here we compare a source-target swap using our model trained on only 2 identities, with the same swap in a model trained on 8 identities. Notice that the 8-way model more faithfully reproduces the target behavior, despite both models seeing exactly the same data for the specific source-target pair. We compare our method with several open source implementations by applying the source identities at the bottom to the target performance at the center left. The original deepfakes method takes on a gauzy appearance, while the stylized autoencoder from Deepface Lab has noticeable difficulty producing a convincing blend. The 3D morphable model approach of Ntr et al. Suffers from pronounced temporal instability, although individual frames can often look reasonable. By contrast, our method leads to clean, high-detail results with no apparent seams or artifacts. Our model allows for a broad range of dynamic information to be represented in the latent space. When we interpolate along the learned manifold, the resulting decoded images correspond to realistic and coherent behaviors that define a clear continuum between their boundary points. Importantly, our method does not simply index existing data, as these nearest neighbor results illustrate.
The system could revolutionize how we search and discover streaming content. Disney's massive archive spans the course of nearly a century of content, which can turn any search for specific characters, scenes, or on-screen objects into a significant undertaking. However, a team of researchers from Disney's direct-to-consumer and international organization have built a machine learning platform to help automate the digital archival of all the content, and they call it the content genome. The CG platform is built to populate knowledge graphs with content metadata to what you see in Google results if you search, for example, for Steve Jobs. So from that, AI applications can then leverage that data to enhance search, discovery, and personalization features, or as Anthony Eckhart, the director of research and development at DTCI, told, animators find specific shots and sequences from within Disney's archive. So if an animator working on a new season of Clone Wars wants to find a specific type of explosion that happened 3 seasons ago, or as a reference to make something for this current season, that person had to spend hours on YouTube going through video, because you can't find that by just looking at episode titles. But with the help of this platform, the animator will be able to simply search for the requisite metadata. So this project began in earnest 2016 after a few years of investigation, Eckhart said. It was really about preparing a company like Disney, operating in a traditional sense for broadcast and home video distribution, for what would we need to take advantage of the differences between a digital video platform with direct access to consumers and the traditional distribution methods. But building such a system from the ground up is no easy feat. Developing a functional and robust taxonomy is vital. And Eckhart is mentioning, especially if you are going to generate a lot of different metadata for a lot of different attributes, you need to start thinking about how you are going to manage those terms and those labels. If you let those taxonomies get out of control, then the resulting data that you generate is going to be hard to take advantage in any sort of sophisticated and scaled way. So the team created what it describes as first automated tagging pipeline. According to this system, it is using a supervised learning, which is regularly employing in custom use cases that require specific detection. So tagging is also the only way to identify a lot of highly contextual story and character information from structured data like storylines, character archetypes, and motivations. And the pipeline leveraged existing facial recognition software, which the DTCI team then applied to its catalog of movies and TV shows. So the module was able to successfully detect and recognize human faces from on-screen action. Following that initial success, the team was able to train the system to detect specific locations as well. So recognizing a human's face from live video is far different test than teaching an AI to spot animated faces. The face of a character in Cars has human properties, but it doesn't look like a human face. So we need something that can learn the abstract concept of face, and with traditional machine learning. And this is now being achieved by deep learning that can be done. So this team tried to apply the live action facial recognition model to animated content with mixed results. Turns out that the machine learning methods they employed work well in picking out color, brightness, and texture changes. So it could only pick out human features, 2 eyes, a nose, and a mouth, if they were within general human proportions. As such, using the systems to tag monsters was right out. So when we look at it, the team had little other choice than to turn to deep learning methods to train the animated facial recognition system. For animated characters, it was really one of those things that there's no other way to do. So it's really what works well as well. So the problem with that, however, is that deep learning training data sets are massive by nature. So instead, the team used the samples it already had to fine-tune with a faster R CNN object detection architecture that had already been trained to detect animated faces using a different non-Disney data set. Basically, instead of training up a brand new architecture using huge amounts of Disney content, the team employed the speedier method of taking an existing, already trained architecture and adapting it to their specific content. And with that, this allowed them to accelerate the processing as fewer detections are required, and then they can propagate the detected faces to all the frames. So ladies and gentlemen, this technology could prove revolutionary for consumers as well. Since the system can be applied to all of Disney studios and all of the broadcast networks, everything from ESPN to the feature films to TV networks, you would in theory be able to search for all episodes in a series containing a specific minor recurring character or prop, where a shot in a specific location or feature for a specific action sequence. So I think it will be a very interesting time to be able to capture those and able to see exactly how we want to by using artificial intelligence and deep learning. So the use of inferencing, the use of knowledge graphs, the use of semantics to really enrich your ability to automate capturing human context and an understanding, that is, ladies and gentlemen, super exciting. My last news is about open artificial intelligence. OpenAI's latest breakthrough is astonishingly powerful, but still fighting its flaws. The most exciting new arrival in the world of artificial intelligence looks, on the surface, disarmingly simple. It's not some subtle game-playing program that can outthink humanity's finest or a mechanically advanced robot that backflips like an Olympian. No, it's merely an autocomplete program, like the one in the Google search bar. You start typing and it predicts what comes next. But while this sounds simple, it's an invention that could end up defining the decade to come. The program itself is called GP3, and it is the work of San Francisco-based AI lab OpenAI, an outfit that was founded with the ambitious, and some say delusional, goal of steering the development of artificial general intelligence, or AGI, computer programs that possess all the depth, variety, and flexibility of the human mind. For some observers, GPT-3, while very definitely not an AGI, could be the very first step towards creating this sort of intelligence. After all, they argue, what is human speech if not an incredibly complex autocomplete program running on the black box of our brains? So GPT-3 is the third in a series of autocomplete tools designed by OpenAI. GPT, ladies and gentlemen, stands for Generative Pre-trained Transformer. So the program has taken years of development, but it's also surfing a wave of recent innovation within the field of AI text generation. In many ways, these advances are actually developing and continue to grow with the AI image processing that took place from 2012 onward. So those advances kickstarted the current AI boom, bringing with a number of computer vision-enabled technologies, from self-driving cars to ubiquitous facial recognition to drones. It's reasonable then to think that the newfound capabilities of GPT-3 and its could have similar far-reaching effects. Like all deep learning systems, GPT-3 looks for patterns in data. To simplify things, the program has been trained on a huge corpus of text that is mined for statistical regulatories. These regulatories are also unknown to humans, but they are stored as billions of weighted connections between the different nodes of GPT-3's neural network. Importantly, there is no human input involved in this process. The program looks and finds patterns without any guidance, which it then uses to complete text prompts. If you input the word fire into GPT-3, the program knows, based on the weights in its network, that the words truck and alarm are much more likely to follow than lucid or elvish. So far, so simple. The first GPT release in 2018 contained 117 million parameters, these being the weights of the connection between the network's nodes and a good proxy for model's complexity. GPT-2, released in 2019, contained 1.5 billion parameters. But GPT-3, by comparison, has 175 billion parameters, more than 100 times more than its predecessor, and 10 times more than comparable programs. So when we look at it, it is really interesting to see what is happening with the OpenAI. And this OpenAI has encouraged these experiments by seeding members of the AI community with access to GPT-3's commercial API, a simple text-in, text-out interface that the company is selling to customers as a private beta. This has resulted in a flood of new use cases. So it's hardly comprehensive, but here is a small example of things people have created with GPT-3. So it's a question-based search engine. It's like Google for questions and answers. And type a question and GPT-3 directly takes you to the relevant Wikipedia URL for the answer. A chatbot that lets you talk to historical figures. Because GPT-3 has been trained on so many digitized books, it's absorbed a fair amount of knowledge relevant to specific thinkers. That means you can prime GPT-3 to talk to the philosopher Bertrand Russell, for example, and ask him to explain his views. So it is very interesting to get to know and understand and utilize GPT-3's elements and able to really develop and continue to see these incredible, impressive ways of areas. So this is not just an autocomplete imaging and not just text, but you can also see it for images. So this is very interesting to see all of these samples that need a little context can have a better understanding. So first, what makes them impressive is that GPT-3 has not been trained to complete any of these specific tasks. What usually happens with language models, including with GPT-2, they complete a base layer of training and then they fine-tuned to perform particular jobs. But GPT-3 is different. It doesn't need fine-tuning. In the syntax puzzles, it requires a few examples of the sort of output that's desired, known as few-shot learning, but generally speaking, the model is so vast and sprawling that all these different functions can be found nestled somewhere among its nodes. And the user need only input to correct the prompt to coax them out. So ladies and gentlemen, I'm very excited to share all of these interesting news with you. Stay tuned to 5 Technologies with NTR at TürkSat. This is your host, Dr. Yavuz Selim Sılay, physician, entrepreneur, and venture architect. See you next time at 5 TN. Take care and all the best. Bye.